All right, moving on to 5.3, which is on slope and rate of change. It says the slope of a linear equation is the rate of change of the line. The slope of a line is often represented by the letter m, so you've probably seen that before with your mx plus b. Okay, and it says the slope of a line passing through 2 points can be calculated using the slope formula. So we're going to check this formula out a little bit more in depth in a second, but probably some stars and bells and whistles around it. It's going to be pretty important for finding the slope. So we have a couple different types of slope here. So we can have positive slope, which means that our line is going upwards, right? So it's rising from left to right. That's a positive slope there. Okay, we can have a negative slope, which is going down from left to right. So something that looks like this. We can have a zero slope, which is just going to be a flat horizontal line. So something along those lines, which is horizontal. And we can have an undefined slope, which just goes straight up and down, which is a vertical line. And that would be an undefined slope. So 4 options there. We have positive, negative, zero, and undefined slopes there. And that's basically describing what our rate of change is, but also how steep is our line. So it says determine if the slope is positive, negative, zero, or undefined. Okay, well this one's rising from left to right, right? It's going upwards from left to right. So this is going to be a positive slope. And then we go to the next one here, which is letter B. We can see this is a vertical line, so this is going to be an undefined slope. We'll keep moving here. Example 3 says find the slope of the line that passes through each pair of points. So you may have seen this before, and we're going to box this up with some stars and bells and whistles. If you have a picture of the graph, you can always use rise over run to find your slope. So that's rise over run, which is going to be the change in y over the change in x. You may have heard that as well. So basically we're going to start on the left. You've got to start on the left here. So this left point starts right there, and the rise is up 1, 2, 3. So we have a rise of 3, and then we're running to the right 1, 2, 3, 4, 5, and 6. So we're going over 6, right? And we could reduce that to 1/2. And so I would say that my slope is 1/2. All right, moving on to letter B, same deal. We can use rise over run there. Okay, and so we're going to start on the left again. Okay, in this case, we're going down 1, 2, 3, and 4. So my rise is actually a -4 because we're going down, and then we're running to the positive direction 1, 2, 3, 4, 5, and 6. And I could reduce that again. This would be -2/3, so my slope is -2/3. And once again, letter C, same idea here. Starting on the left, always starting on the leftmost point. We're going down. Let's see. Looks like we're going down 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going down 9. So that's a -9. And then we're going over 1, 2, 3. So my run is just 3, which would just give me a -3/1 as my slope, which we can just write as -3, of course. And then finally, letter D, same idea, starting on the left. Okay, up 1, 2, 3, 4, so a rise of 4, and a run of 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's nothing we can do to reduce that there, so that'll be my slope, 4/9. Okay, but what about if we don't have a picture? Then we're going to have to use the slope formula. The slope formula is on the other page that we just looked at. Remember, I'll write it down so we have it off to the side here. It looked like this: m equals y x2 minus y1 over x2 minus x1. And so for this part, they give us 2 points. And I can label these differently here. So I'm going to call this one x1 and y1. And here we have x2 and y2. And I could have flip-flopped these, right? So I could have labeled these points over here as the x1 and y1, and these over here as the x2 and y2. It doesn't matter, except you have to remember that x is always first and y is always second, and the 1s have got to be together and the 2s have got to be together. Okay? And so we'll go ahead and plug this into our formula here. The formula says y2 minus y1. So we have m equals, let's see, that's going to be 3 minus 15 over 5 minus 9. That's x2 minus x1. So that gives me negative 12 over negative 4, which just gives me a positive 3 as my slope. We'll keep going here, same deal. x1, y1, x2, y2. And into our formula here, m equals y2, which is 2, minus y1, which is negative 4, over, let's see, 2 minus negative 2. Okay, we got to be careful here, right? Because we're subtracting negative numbers, and that's a keep change situation. So that actually turns into addition on both of these here. And so we're going to end up with 6 over 4, which just gives me, we can reduce that a little bit to 3 over 2. And you can leave it as a fraction. You don't have to turn it into a mixed number or a decimal. Moving to letter C here, same idea. We've got x1 and y1 and x2 and y2. And so into our formula here, it's going to be 1 minus 4 over negative 4 minus negative 4. And so we get 1 minus 4, which is negative 3, over, again, we have a keep change, right? Minus a negative, so that turns into plus. So it's actually negative 4 plus 4, which is 0. And you might remember you can't divide by 0. And so this is going to end up being an undefined slope. And so hopefully in your head right now, you're picturing that this would be a vertical line on a graph, straight up and down on a graph. And then we'll get to letter D here. So again, we've got x1 and y1, x2 and y2. So it's going to look like this, negative 3 minus negative 3 over 4 minus 0. Again, minus a negative is going to turn into plus there. And so this time we end up with 0 in the numerator on the top of my fraction. Okay, and that's okay. That just means that my whole slope turns into 0. So that whole fraction just turns into 0. And so if you were to graph it, hopefully you're picturing that would be a horizontal line. All right, last part here. It says the slope of a line can be used to represent the average rate of change or how much one quantity changes relative to another. A slope that is a real-life rate of change involves units of measure such as miles per hour or degrees per day. It says a giant sequoia grew from 137 inches in diameter in 1965 to 141 inches in diameter in 2005. Find the average rate of change in diameter of the sequoia over this time. So basically what they did here is they gave me coordinates 137, and that was in 1965, right? So that's like 137, comma 1965. Right, that's the year. And then my other point here would be 141 in 2005. And so I can use that same formula, right? y2 minus y1. So that's going to be 2005 minus 1965. So I subtracted the y values, right? y2 minus y1. Okay, over. Subtract the x values, 141 minus 137. Okay, and so then from here we can go ahead and do some quick math here. This is going to be 40 over 4. All right, and now we have to reduce this a little bit here. So this ends up being just 10, or 10 over 1, right? I'm going to write it as 10 over 1 because we have a context of a word problem here. So now we have to remember what this is all talking about here. So remember, in the numerator we have the years, and in the denominator we have the inches of the diameter. So what's happening is that this thing is growing 1 inch. It grows 1 inch in 10 years. And that would be the average rate of change over that time, 1 inch every 10 years. All right, thanks for watching.